Hello and welcome to this video in which I will introduce the concept of source code management and how you can use it for development projects for Microsoft Dynamics 365 Business Central using Visual Studio Code and Git repositories. My name is Daniel Rummelswan and I'm a partner with Cloud Ready Software, one of the ISV development centers who can help you with just about anything related to Microsoft Dynamics 365 Business Central. Here are the objectives for this video. First, I will introduce the concept of source code management in Visual Studio Code. To make this work, you have to install Git itself first and prepare your Visual Studio Code environment. Next, I will explain how you can initialize and use Git repositories. In this section, I will show you how to create a repo in GitHub as well as in Visual Studio Team Services, also known as VSTS or Visual Studio Online. In the last section, I will talk about how you can use Git for your VS Code development project for Business Central. You can get quite fancy and sophisticated, but I will keep things relatively simple for this video. Let's get started. In the overview section, I'll start by introducing the concept of source code management and how that integrates in Visual Studio Code. Source code management is an integrated feature of Visual Studio Code. There are many different protocols that are used for source control, and one of the most popular ones is a protocol called Git. Git was selected as the preferred source control protocol, and VS Code was designed to have native support for it. This means that VS Code integrates with Git out of the box. You first have to install it though, which I will talk about in a few minutes. Other SCM providers are available for many additional technologies. The difference with Git is that to support those other protocols, you will need to install the appropriate VS Code extension to be able to use them. Some of the most common ones are VSTS, Mercurial, SVN, and Perforce. I will show you how you can find them in VS Code. Since multiple extensions can be installed and activated at the same time in VS Code, multiple SCM providers could be active at the same time. One provider can handle source code changes, another provider can handle documentation on the same project. Each provider has separate filters for including files and therefore allows finer control of what is being managed. In Business Central project, for instance, you could put different providers to use for different project areas. You could handle report layouts separately from AL development. You could handle upgrade code separately from business logic development. You could even handle profiles and personalization separately from UI development. And all these different types of things could be tracked using different source control providers. For this video, though, we will keep it simple and we'll stick to just Git. I will show you how to create a new repository in GitHub and also in Visual Studio Team Services, also known as VSTS. And I will also show you how you can link code changes to work items in VSTS, which is a very useful feature. The Git protocol operates on a local file system level. From VS Code, Git commands are forwarded to the OS and actually handled by the protocol itself. The commands are issued from VS Code, but they are executed on a local file level. In order for VS Code to be able to do this, you must first install Git itself on the same machine that you are running VS Code. This is an essential first step to make Git work. In this next section, I'll show you how to install Git and how to set it up for use in Visual Studio Code. As I've mentioned before, Git is a source control protocol, and there are a number of ways to install it. The recommended way to do this is to download the program from git-scm.com. Every time that you start VS Code, it will check whether Git is installed, and if it can't find it, it will show you a message about it. And this warning message then has a button that takes you straight to the download page. The installation process itself is extremely easy. Just accept all the default installation settings and you'll be set. After the protocol has been installed, you need to set some global settings to identify yourself to the system. Those settings will be used when working with your repositories. Let's go to the development environment and let me show you how to do all of that. We are back in the Azure VM where I have Visual Studio Code installed and where I have my nav server container. So when I open Visual Studio Code, you will see that it's going to check for Git. And when it doesn't find it, I'll get a warning message. So here it says Git not found, install it or configure it using the git.path setting. Now you can do this all manually, but the easiest thing to do is to just click this download Git button and it'll take you straight to the download page. We'll do that in a minute, but I just want to show you first that Git really is not installed. So when I go into the command palette and I type in a Git command, for instance, git clone, as soon as I issue it, the system will tell me command git.clone is not found. And the reason for that is that the underlying protocol has not been installed yet. One other thing I want to show you is that you can go into the extensions, and when you search for a category SCM providers, you will see a number of different providers that you can install for Visual Studio Code. And so here you can see Perforce, there's SVN, there's Visual Studio Team Services, which we will install in a little while. But I just wanted to show you that this is where you can find other SCM providers from the marketplace. So let's now click on Download Git. And when you click on that, we'll go straight to git-scm.com. And there's the link to download it for Windows. And then from here, you just run it straight. It'll download it, security scan, and then it opens the setup wizard. As soon as this starts, you can close the website. We don't need that anymore. And now we just click next 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you hit install, and that will install the protocol. That's how easy it is. That's how quickly it goes. Let me just pause the video for a second to compress the time a little bit. And when the wizard is complete, you'll get the finish screen. Uncheck view release notes. We're not interested in those, and click finish. And then all you need to do is restart Visual Studio Code. You'll see that it'll check for Git and it will find it. And in the output window, you'll see that it's using it. So now when I go into the command palette and I issue git.clone, it'll ask for a repository URL. So since the protocol has been loaded right now, you can use it and use the git commands from the command palette. Let me just mention some Git terminology that's important to know. When you hear a developer talk about a repo, what they mean is a repository. And a repository means it's a project folder that contains all the files that belong to an individual project. And so Git, just like VS Code, looks at a folder as a repository. And so the same folder can be a workspace for Visual Studio Code, and at the same time, it can also be a repository for source control. And so two systems look at the same folder from different angles. The second term is a remote, and a remote is a version of the project that is hosted on a remote server that can then be synced with a local repository. What Git does is it creates a copy of the remote on your local drive, and so you have a local repository and a remote repository. The clone is the name for the local copy of a remote repository that allows you to work offline. So when you're doing your work in a decentralized manner, which means that you have your own environment as a developer, you are working on a local copy of the remote repository, and the word for that is clone. Push and pull are sending and retrieving committed changes from a local repository to remote or vice versa. So you push a committed change from local to remote, and you pull a change from remote back to the local repository. Fetch is the same as pull without merging the change. This can then be done manually later. Then another important concept, which we won't talk a lot about in this video, is branching. A branch is a version of a repository that is different than master. which allows you to work without disrupting the quote-unquote live version or the master version. So you can imagine you have a master version of the repository. You want to work on a certain feature without being disrupted by the work of other developers. You can then create your own branch, do your work on your own branch at the same time that other people are working in other branches. And when each developer is done, those changes are then merged from the branch into the master branch. And so that process of applying the changes done in one branch into another branch, that's called merging. And so most commonly, changes are merged from a developer branch or a feature branch or a release branch, or however you want to set up your development project in branches, however you want to define that. But at some point, the work inside of a branch will have to be merged into the master branch, and that process is called merging. Before I move on to the next section, I want to show you a very interesting post on the nav team development blog. The nav team has written a blog about how they use branching, and essentially this is an illustration of how you can use source control to manage different types of development tracks. And so this is an article that was written back in May this year, and this was to explain how the developer preview branch and the NAV 2018 branch, and then after that the Business Central branch relate to each other in relation to the main branch. And so if you can see here, this is about the AL development. And so over here you can see a picture where you have the main branch in the middle, and then on the bottom here you see another branch that follows the GitHub issues. In that branch, GitHub issues are developed and fixed, and then those changes are pushed into the main branch. And from the main branch, then the September update was released, some new fixes were made, then the October update was released, some new fixes, and then November, et cetera, et cetera. And at some point, they introduced Dynamics NAV 2018, which from the main branch was released into a different branch, and from that branch, NAV 2018 was released. And after a month, CU1 was released, and after a month, CU2 was released. And so you can see that the branch from which NAV 2018 was developed is a different branch from the main branch, but they both have the same code base. So it's like a simultaneous track that goes on at the same time, where certain issues are fixed and put into the main branch, and not all of them are put into the product release branch. And so from the product release branch, at some point, Business Central was released. So all these fixes go into the main branch. At some point, that gets released into Business Central. So Business Central still has the same code base as NAV 2018. And at some point, you get another major release, and certain things are moved from the main branch into the product branch in case of hot fixes. Anyway, I just wanted to show you as an illustration of different branches being part of the same product, the same development code base, where you have the same product, you have the same features, the same functionality, the same objects. They're just in a different stage chronologically in relation to the main branch. And this is just one example of how you can do it. You can, of course, do it your own way entirely and make up what works for you. So that was that part. Let's go on to the next section, which is called Managing Repositories. As described, repositories are folders. In folders are objects. Those objects are represented by files. And just like the difference between Visual Studio Code, where it looks at it from a workspace point of view, from which the app file is created and deployed to the service tier, source control looks at a folder from the point of view of tracking the changes in those files and keeping different versions in the repository. There are two ways to initialize a local repository. So a folder, a project folder, a workspace is first has to be recognized by source control that it is a repository in the first place. And in order to do that, you have to initialize that workspace as a repository. And so there are two ways to initialize a local repository for Git. The difficult way is to take an existing folder and then apply the Git commands to that folder, initialize it as a Git repository, and then that would create the local folder as a repository, which you then have to push to a remote. And the easy way is to clone an existing Git repository from a remote, because usually the repository management system like GitHub or Bitbucket or Visual Studio Team Services have very easy ways to create a new empty repository. Often they have little things like creating a Git Ignore file, putting some template files in there, that sort of thing. And then when that is done, it'll provide you a link to clone that remote repository down to your local file system. And so that's the easy way to do it. Open Visual Studio Code, you access the command palette, then you enter git clone. I've already shown you that command. Then it asks for a URL for the Git remote. Then you point to a local parent folder, and then it will download the cloned repository from the remote into your local folder, and it will create a project folder inside of that parent folder that you've pointed at. And then Visual Studio Code will ask you, do you want to open the repository? You click the button, and from that point on, you're in. The less easy way, we say less easy because once you know how to do it, it's really simple, is you initialize the local repository and then you push it to a remote. First, you open Visual Studio Code, then you create a local workspace, you access the command palette and you run git initialize repository, and in the terminal window, you would set the origin to a Git remote, and then you hit synchronize, and that pushes that into the remote. Both methods are easy to run. Personally, I like the Git clone, but that's because I'm lazy. So how do you choose? Clone is when you have an existing repository, so the remote already exists. This happens when you join a development project that's already underway, or when you join one of our workshops. We have some repositories that we pull for lab work, that sort of thing. So you're configuring a new environment to connect to an existing project is essentially what that is. And you want to form an existing project that you want to spin off. So it's easy to create a clone, then copy some of those files into a new workspace. If you want to use source control, but you don't want to have a remote, you can do all your source control locally only. In that case, you would initialize the Git repository locally without pushing it to a remote. So you can even do that without even initializing or setting the remote. Git will work locally only. Keep in mind, you can initialize a local repository over an already existing folder that has files. So you can do a lot of development already. You have a full workspace. In the workspace, you have hundreds of objects. And then at some point, you decide to put that into source control. You can initialize that workspace as a Git repository, and it'll pick all those files up. All you need to do is commit them to your repository, and you're set. Let's go back into the Azure VM, and I'll show you how to initialize some repositories. So first, what I want to do is create a new AL workspace. So we'll use al.go. We'll just accept AL project 1 as the name. We'll use our own local server, which creates the launch.json, and we'll just escape out of this one. So now we have a completely empty AL workspace. And so if I browse to that folder, you can actually see what's in there. If you've already done the development videos, or if you've already worked with AL files, you know that this is a properly configured workspace. Now, for the less easy way, what you would do is you would issue a Git Initialize Repository command here. You would then go to the server prompt to set the remote, and then you would sync to get this into your repository. I'm lazy. I want to go the easy route. And so what I'm going to show you is how to clone an already existing repository. Before we do that, though, we have to set some global variables in the system so that Git knows who we are. And so for that, we go into the terminal. And inside the terminal, we have to issue a few Git commands. So for Git config -- global, and then we set the user.email, and then you set it to u@example.com. Git global user.name, Daniel Rimmel Zwan. And so with these settings, Git can now identify who you are, right? So the source control management part is to keep track of all the changes. You need to know what the changes are. You need to know who made those changes. So then we go to GitHub, and for this I've created a sample repository. So on my GitHub page, you see that I have a number of repositories, and one of the repositories is a GitHub demo. And this GitHub demo is a completely empty workspace. And this completely empty workspace is based on a template. I like to have a Git Ignore file. I'll explain in a minute what that does. And when we clone this repo, you'll see how that comes through in the folder. And I'll show you how that looks. So first thing you do is you go to the clone or download link. Then you copy this URL. Then you go back to Visual Studio Code. We hit Control-Shift-P, and then we select the git clone command. We paste the repository URL into the box here. You hit Enter, and then let's just select the folder that we've been using for the location of our AL workspaces. So we select that as a repository link, and now it downloads that folder down into the local folder. So just to show you that this is actually working, I have a GitHub demo folder in my AL folder now. And if I open that, you'll see a hidden folder called Git and a Git Ignore file. And so that corresponds with what we've seen in GitHub, right? In GitHub, the only thing in the repository is a Git Ignore. And for Git to recognize that this is a Git repository, you need this hidden folder. So back in Visual Studio Code, you can now open the repository, and that opens that folder. And you can take a look at Git Ignore immediately. And now you see that there was like a little icon here. And in the bottom, you see that now I am looking at the master branch of my repository, and some other icons are available in the status bar as well. So let's go into Git Ignore and select everything and delete. Give ourselves some room. And what I am going to do is I am going to add something. First is a comment. Unnecessary to track the *.app file. Because app files are generated by my development work, I don't want to track this in source control. So now if I hit Control S or save, watch what happens. Now you see in the source control that there is a number. And in there, I can see that Git Ignore has been changed. If I click on that, it'll show me both versions of the file. So on the left-hand side, I see the old version of the file. On the right-hand side, I see the new version of the file. And all the way on the right here, you see what's called the gutter indicators. And so in here, because we don't have a lot in there, all the code fits in there. But you can imagine if you have an object that is pages and pages long, it's very useful to have an indicator like that, because you can click on it and it'll take the cursor to that change. So all I need to do now, because this is set as a change, it's not set for commit yet. The next step is to stage the change. that prepares it for committing into the local repository. So then if you want, you can add a message, modified Git Ignore. It's a meaningless message because you can see that Git Ignore is the only change, but I just want to show you an example of what this looks like. So at the bottom, now you see there is a committed change, number one, with an up arrow ready to be synchronized. So if I click on this guy, you will see this action will push and pull commits to and from origin into master. Okay, don't show again. I know what that button does. And now it's going to reach out to the remote and it's going to push the committed change from my local repository into the remote repository. GitHub only wants to let people in that it knows. So my email address for GitHub is password, of course. And you click login, and now it's going to go out there and it's going to push that commit into the repository. Do you like to do fetch? Let's not do that. But this is an example of I have a little repository. I made a little bit of a change. And now if I go back in here and I refresh this guy, I should have 2 commits. And so the first commit is when I created this workspace or this repository, and I can click on this guy and I can actually see the changes that are part of this commit. So this on GitHub is the remote. What we're looking at here is the local repository, and this is how it works in GitHub. I have also prepared a demo in Team Services. And if I go there, you will see that there is also a link for cloning the project. So you can copy this, copy, go back to Visual Studio Code, hit Control Shift P, go to Git Clone, paste the link to that VSTS demo in the repository URL, and then it's going to ask for the same kind of thing. So we select AL as the repository location, and now it's going to clone that Git repository from visualstudio.com. It's going to ask me for credentials, sign in. And now it has created the same kind of repository locally, and I can choose Open Repository. So now I have another demo for which I have a folder. So if I go into the AL folder, now I also have a folder, VSTS demo. And as you can see, there's also a Git folder in there. So one of the things I would like to do is I would like to copy my Git Ignore file into my VSTS demo, copy the file. Now you can see that that's a green file and it shows up as a change. Create Git Ignore, put that as a stage change, hit source or hit commit, and now it should say publish changes. So slightly different, but still it's supposed to be able to identify the change and push it into the remote. So now that should be completely done. I should be able to go into code. And inside my code, I can see I have a Git Ignore that was not there before. I can go into the commits and I can see that in my commits, I have a commit with a message, create ignore. And if I click on that, I can see the change that was part of the commit. That's really it. That's how you initialize a repository. In the next section, I'll talk a little bit about how to work with Git, and I will also show you how you can connect to the actual project in VSTS and how you can connect a change that you're making to the work items that are part of the project. So let's go back to the presentation and go back to the next section, which is called Working with Git. In this section, I'll talk a little bit about how to work with Visual Studio Code and Git and kind of what it's like and how the process works. So let's get started. Git automatically tracks the changes and shows the information about those changes and the status on screen. So in Visual Studio Code, you can just do your work and just develop like nothing's happening. And as soon as you save the file, Git will recognize that you've made a change. So in this screenshot, you see that I am in the customer card extension. I have just saved it, made a change and saved it. And now on the left-hand side in the activity bar, you see this little token here that says a number 1. So in source control management, it recognizes that there is a change to one of the files. At the bottom, you can see that I'm in the master branch of a repository. And I have 2 committed changes waiting to be pulled from the remote, and I have 1 committed change to be pushed to the remote. And so that's like an indicator of the stuff that is happening in your source control management. So these indicators shows the number of changed files. If I have more than 1 object that is changed, it'll show the number of files that I've changed. Current branch, dirtiness of the current branch means this little asterisk means that my branch is not updated. It's out of date, out of tune, out of touch. You need to update that, and you can do that by clicking this little button in the status bar. I've also shown you on the right-hand side, you have the gutter indicators. These are those colored blocks in the scroll bar. So on the right-hand side, there is like a representation of the file that I'm currently working in, and most of the stuff that is in that current file fits in the screen. So this is a fairly small file that is currently in the screenshot. But if this object is pages and pages long, you would see like a section highlighted in here, and you can interact with that gutter indicator as well. So you click in the middle below the currently highlighted, that will put the cursor right into that block. It's very useful, especially when working with larger objects. That also works in the compare part in the source control part. So at this point, I have the customer card extension working tree, which is what shows in this source control pane when there is a changed object. So on the left-hand side, you see the old version of the object. On the right-hand side, you see the new version of the object. And this is an example where the gutter indicator highlights this part of the object file, which is currently in the screen and above my current selection. So that's like up here, there are some other things that were done to the file. And so you could click on that and that would put the cursor right in that part. And the cool thing about this is these are both editors. And so in the current version of the file, you can actually make a change. So if you see that a change that you've made is not correct, this is like a final way to do like a code review kind of thing. So these are actual editors. Then the next step, when you save a file, it is changed, but is not recognized yet by the repository. And so to get that change into your repository, you have to do what is called a commit. And so to be able to commit, you can actually select the changes that you want to commit. So if you've made a change to 5 files, you can select just 3 of them and make that part of a commit. And that's what I've shown you before. That's where you stage the change. And so you see 5 modified files in the source control pane. You click the plus on 3 of them. That puts it into the staged changes. You can then add a commit message, click on the check mark, and that takes those changes and commits them to the local repository. And so that's the second bullet point. After the work on the code is done, changes are first staged and then committed. And so both staging and committing are local actions. We've only made those changes to the local version of the repository. And then finally, to get that from the local repository to the remote repository, if you're the only one, all you need to do is push those changes into the remote. If you're part of a team, which most of us are, you might see other changes that are already in the remote that need to be pulled, and in that case you hit sync. And usually on the status bar it's just a single button. You click on that button and then Git takes care of all the changes for you. I've gone into branches a little bit, and I really want to leave it at that. I could talk about branches for a very long time. These are the commands that you can use to work with branches: git create branch, git delete branch, merge and publish branch. Publish branch is if you create a branch locally, you can say publish this branch, and that puts your local branch into the remote. What you could do though is pull the branch, the master branch, down to your local repository, then create a local branch, a temporary branch, do your work, then merge that branch back into your local repository, and then push that commit into the remote. And then the remote will never see your local branch. That's one way to do it. There are many, many, many different ways to do branching. If you are just about to get started with source control, don't bother about branches just yet. Unless you're part of a company that already has a branching method in place, then you can go to a senior or something to get an explanation. But that's about it that I wanted to share about branches. Synchronizing changes is where you pull the pending incoming pulls and push all the pending outgoing pushes, and merge is performed in the same operation. So if you do a synchronize, that pushes and pulls and merges in one action. And so the push is pending outgoing pushes to a remote. So if you have local commits that have not yet been put onto the remote, you push them into the remote. If somebody else has made some changes to the remote that you don't have yet, you do pull, and that pulls all the pending commitments from the remote into your local version. Merging conflict happens when there is a change on the remote that conflicts with a change that you are about to push into the remote, or if you've made a change to your local and you pull a change from the remote that conflicts with what you've had, with what you have locally. Either way, it'll be presented to you as a conflict. You can click on that conflict and you'll have to resolve that on your local copy before you can do a new synchronization to the remote. And so this is what that looks like. You'll see there's two messages made in the same place. There are two differences in there. And as you can see, there are like these little actions that you can take. You can say, accept the current change, accept the incoming change, accept both changes, compare changes. And those are also actions that you can click on. In Visual Studio, you can then address that in the editor, and you can decide what to do about those changes. But the general rule of thumb is whatever's on the remote should win. So whatever is on the remote is what you should accept, and then you should like redo the work that you've done, but in a way that does not conflict with the changes that are coming from remote. And for NAV development, that might be fields, right? So somebody else has added a field with the same field number, for instance. The way to resolve that is to change the field number on your local version, because chances are that the one on the remote has already been published. So you have to be careful how to do that. And so there, you have rules and agreements amongst your team members on how to resolve these conflicts. That was it for the presentation part. As promised, I am going to show you how you can link changes that you've made in code to a work item in Visual Studio Team Services. So VSTS is more than just a source code management tool. You can also actually manage project work into work items like product backlog, items, features, epics, bugs. You can do testing, you can do build. I'm not going to cover all of that. All I'm going to do is I'm going to show you how you can connect to a project in VSTS and how you can assign a committed change to a work item in VSTS. So let's go to the Azure VM and let's get started. First, what we need to do is we need to look for the Visual Studio Team Services extension for VS Code. You click on Install, and when it completes installation, you reload Visual Studio Code. And at that point, you can see that it has been installed. Now you're going to get a message, welcome to the team version. Let's just click this guy away. First thing that we need to do is we need to connect. Now it's trying to connect to team services, but it's not connected yet. So now we can go to Control-Shift-P, the command palette. And in the command palette, we can select team sign in, and then we can authenticate and get an access token automatically. This is very handy. You just copy this guy and then you hit enter, and that opens the login screen for VSTS. And in this login page, you then paste the code that we've just done. You see a different code here because the previous one failed. So I skipped to the next part in the video. Then you hit continue. You have to select an account and probably log in with that, sign in. I've already done that before, so it knows. And now it should have authenticated my access to Visual Studio Team Services in my device. And so as you can see now, it has VSTS demo, more information on the Team Services part than I had before. So let me just go back into the project on VSTS, and I will show you the parts that I've already prepared for this demo. In my VSTS demo, I had the code, and inside the code, we had the commits that I've already shown you, but I also have something called work. And inside the works, I have something called a backlog. This project was created using the Scrum template, and in Scrum terminology, you have something called an epic, and then you have something called a feature, and underneath features, you have things called product backlog items. And so I have an epic app example, I have a main feature, and I have a product backlog called Initialize Repo. And in there, I'm going to create a task, and this is Initialize Workspace. And I'm going to assign this to myself. Save and close. And now I have a task that I have linked to myself in Visual Studio Code. Now there's a lot to learn about VSTS. I'm not going to go into all of that, but just I wanted to show you that you can have all these tasks, and you can of course create a list of epics and features and product backlog items and tasks and all that stuff, and assign it to sprints and all that good stuff, and plan your way out there. I'm going to leave that out of this video, but I do want to show you how you can then take the code that you're creating and link it to a task that's outstanding in that project in VSTS. So for that, I have another thing. So that AL project that we've created before, that was that sample. I'm just going to copy that into my VSTS demo. And when I paste that in there, I can go into my editors. And in my editor, I can see that I have the launch.json and the app.json and then the hello world and everything in there. And so it recognizes those changes in source control. Let's say we're going to stage all those changes. And now, because I'm connected to my project in VSTS, I am able to say I'm going to associate work item to my change. And so I have a task and a product backlog item. I want to say I want to link this to the task Initialize Workspace. And so the #22 is the way that you can link to work items. And of course, I'm just not going to just default to the title, but I copied AL workspace files. And now I commit, which puts it into the local repository. And now that shows up as a committed change that needs to be synchronized. And so when I click on that, it'll synchronize that piece into the VSTS system. And now that that's done, when I go back into my VSTS project, I can now click on the task Initialize Workspace. And as you'll notice that there is a tab here for links. And when I click on that, I can see that there is a parent Initialize Repo product backlog item. And this is the commit that I just synchronized from Visual Studio Code. And that takes me back into that commit, and it shows me all the changes that were made. So now I have in my VSTS project, I have an overview of all the tasks and all the work items that are in there. And I have commits in source management, source control management, and now I can actually see and connect everything together. So you can imagine that you can have a development project that has tasks and project management and work items and all those types of things. You can go to Visual Studio Code. All your work is being tracked. You can link it to work items. And this becomes something that you can really benefit from as a team. So you can go into the project in VSTS. There are tons of additional extensions in VS Code as well. Git extensions where you can see one is called Git Blame. So you can hover over a piece of code in one of the objects and it will show you who made the change at what point. I don't have that particular extension installed at this point, but you can imagine there's a lot of stuff that you can add to Visual Studio Code and that sort of thing. VSTS, by the way, has build and release. It has automated testing. It has all sorts of goodies that you can really use in your development work. That was it. All that I wanted to show you for this video. If you want to learn more about Business Central apps, go to the link on your screen. And that leaves me to say thank you so much for listening to me. I hope you have some value out of this video. And I wish you have a pleasant rest of your day.